And here we are again. We've got double angle formulas well in hand. And so the question might arise, well, is that enough? Do we have enough now? And, well, still no. I've got another question for you here. What's the cosine of 7.5 degrees? What's the cosine of 7.5 degrees? So rather than starting to double things, let's cut things in half. Because we can do the cosine of 15 degrees, right? After a little bit of manipulation for the sum or difference formula for that, we end up with root 6 plus root 2 all over 4. And we also have the double angle formula. Cosine 2x is 2 cosine squared x minus 1. So should we not be able then to solve for a cosine of 7.5 degrees, because double that is 15 degrees. So I've got an equation here. Known is 2 unknown squared minus 1. Can we not solve for cosine of 7.5? And yes we can. Let me show you how. See, how we can do this is, and this is also a little bit of notation, right? To the way we get at that thing we want, this cosine squared of unknown, we can add the 1 to both sides, divide off the 2, and take the square root. And with a little bit of change in notation, this is just how we notate or denote half angles and half angle formulas. If we have something that's half of something we know, if we have an angle that's half of another angle that we know of that one, then we can, after taking the cosine of that thing, adding 1, dividing 2, taking the square root of that, we now have the cosine of that half angle. And actually, you can do this again for sine, just by doing the other form of cosine 2x. And it's kind of funny that cosine of 2x, the double angle formula for cosine, is arguably the most important additional formula that we'll get to in the rest of the course, because of all the other forms that come out of it. See, cosine of u over 2 comes out of that, sine of u over 2 comes out of that, and as we'll see in a bit, we will also get tangent of a half angle using these same forms. Before we do that, though, we now have what we need to evaluate cosine of 7.5 degrees. It's going to be the square root of 1 plus cosine of 15 degrees over 2. And what about this pesky plus or minus, you're asking, right? When you ever take the square root of both sides, you have to have a plus or minus. Well, that's the thing, right? Cosine can either be positive or negative. This square root expression is always positive. So we pick the positive of the plus or minus whenever this angle is positive in the cosine. And we pick the negative part whenever cosine of the half angle is supposed to be negative. So it really depends on the angle which side we pick. Now then, because we're in the first quadrant, we are going to take positive square root of 1 plus cosine of 15 degrees over 2. Or positive root 1 plus root 2 plus root 6 over 4 all over 2. And cleaning this up a little bit, we get exactly the exact value of cosine of 7.5 degrees is the square root of 4 plus root 2 plus root 6 all over 8. That is the exact form. Kind of nice. We can do that now. And of course, we could then cut 7.5 degrees in half, get the cosine of that or the sine of that, and just keep cutting in half over and over again. Should we? Probably not, but could we? Yes. Now then, right, we've got the half angle for cosine, half angle for sine. Let's look at the half angle for tangent. Right, tangent is sine over cosine. So with a little bit of quick substitution here, we've got 1 minus cosine over 1 plus cosine. The over 2's, the halves inside each will cancel. So I'm looking at tangent of u over 2, or theta over 2, being root 1 minus cosine u over 1 plus cosine u. And if you want to stop there, well and good, right? Just pick the plus or minus according to whatever quadrant u over 2 is in. But if you want to be fancy, we can go a little bit further with that. We can multiply by the appropriate rationalizing thing. One way to do it is to either rationalize the denominator by multiplying top and bottom by 1 minus cosine u, But actually, it's going to work out that if you rationalize the numerator, you end up rationalizing the denominator as well. Multiplying through by 1 plus cosine u, top and bottom inside the square root, gets you to 1 minus cosine squared u, which is sine squared u, and 1 plus cosine u quantity squared, which is another perfect square in the denominator. So after you take the square root of sine squared, you get sine. After taking the square root of something squared, you get that something. All inside absolute value, though, because, right, sine squared is always positive. This perfect square is always positive. That square root's always positive. So if you want to do the half angle formula for tangent, you take the sine of that angle, divide that by 1 plus the cosine of that angle, make whatever that thing is come out to be positive, and then finally affix the right sign, the right SIGN sign, plus or minus, depending on where u over 2 is in, what quadrant. Or equivalently, that form right there. That's how you do it. So let's see here. This gives us the nice, tidy half-angle formulas that we will have on our formula sheet for the rest of time. Sine of x over 2, right, just relabeling variables, we get sine of x over 2 is plus or minus 1 minus cosine of x over 2 inside a square root. 1 plus cosine x over 2 gets you the cosine. And then lastly, we get some special manipulations to get tangent. And that's all I wanted to get us into in this one. That is all of the formulas we want to worry about right now. In the next video, we'll actually pick up right here. Because with a little bit of clever rewriting, we actually get another set of formulas straight away. And those are the power reduction formulas. But I will worry about that. We'll worry about that next time. So I'll see you then. Let me know what worries you are having with what we're doing. And have a good one.